Hi, welcome to my channel about embedded systems, robotics and fischertechnik. If you're new to my channel or haven't subscribed yet, please subscribe via the thumbnail in the bottom right corner. As you can see, the focus of this video is my walking robot Mirft2, which is made from fischertechnik and based on the TXT controller, which runs embedded Linux and is programmed in Python. Last time I finished with the conclusion that the battery packs are actually limiting the functioning of the robot, in the sense that they are quite heavy. They are nickel metal hydride batteries, and this is the battery, rechargeable, NIMH, and they're quite heavy. So last time when I found that it didn't walk, while it can walk, it has proven that, lifting both batteries off of the robot, it walks. So the question is, can I in some way make it walk while the batteries are not on them? Well, maybe extending the wires. But that's obviously not the purpose. Then another point is color recognition. Let me move the camera a bit. So this is the USB camera, and these are the objects. And the purpose is still that it can read or actually grab a picture, decide what's red, decide what's not red, and then walk towards it, and then eventually with these two sensors touch it and stop. So there's still something to gain. Anyway, to see how everything works out, let's go to screencast and see whatever happens. Like I said, screencast, and first of course the camera to the robot, then two terminals for the actual presence on the controller, to which I still have to set the date, by the way. So let me do that first. 39/13. Today is the 15th of September. And exit, enter source code. And here I can just run it. First, battery pack check. Last time with the Discovery, the driving robot, I had some issues with battery packs, either being drained or not quite drained, and giving me power problems. So I hope these will not give them this time. Anyway, both say 9, that's good. The difference is, of course, that here I do need both, otherwise it won't do anything. Whereas with the other robot I can do with one. Anyway, let's run. 2.5 seconds for the camera. Speed. Well, it's going, of course, but it walks. And last time it certainly did not do that, because Okay, and that because of the camera weight. So another question arises now. Why doesn't it do what it should do one time and now it does do what it should do? Apart from the straying away from the course. Let me take you to the images taken, because it's still about the camera as well. Then you see that it is actually straying away. Here you have the head-on picture, and right here the stray away, where it strays away from it. And actually those pictures are quite nice. There are only 2 pictures taken as far as the results go. So actually I should see that there are more things being done. And what is the exact condition that things go like it should go? Well, I check only for motor rest finish, rest being right side, right hand side. I actually never check anymore for the sensors to be touched, because in order to check that I should take the robot very close to these objects, and it doesn't walk doesn't walk enough for that. So I'm going to try now to make it walk longer. I have changed the algorithm with respect to writing to the data file, and if you can see here, speed is 450, and this is distance for the motor on the right hand side, while when I go to the ultimate start, I see a problem because it says set the distance to 2350 and it has to count down. So that's not quite what it should do. So let me run again after setting the robot straight, and let me first check the battery values. Still going strong at 92. Very good. Go. Yep, 450. Rattling of the gears, which I don't like, but it runs off the camera, which is nice. And here it has a flat surface. Oh, this is very nice. This is a very nice run. So if I put it a little bit closer, it will touch the subject, the object. I like this. I like this a lot. Yes. Next step. Looking at the data file and looking at the images. I have only looked at the distance now, and look what's happening. So distances are 0 at the beginning, but look at this. It is not counting down, it's counting up. So for some reason it starts at 800 something, then 1700 in the next loop, and 23,500 in the final loop, which is exactly this one. So it has a completely fulfilled loop. Regarding the distance, it is about the size of the robot itself. So that I don't have to increase. I could, but the question is, should I? Okay, that's for the, no, here. And there are indeed 3 images to be to look at. "100%, 100%, and 100%. So let's do that. That's one to start with. Next, already straying away. And the final one, no. This one. Yeah, straying away completely, which is good. Well, straying away isn't good, but it shows the whole path. That is good. So, next thing, final thing for now. Hopefully it cooperates. Let's check the battery setting, battery voltage, which is quite alright still. So I'm going to put it back, run again, and then see whatever happens. So everything's set. Let's run and hope it will run fine. Okay, go for it. Make me happy with touch sensors as well. No, it won't. It is not. No, it is not making me happy. Data. No, only 2 runs, not 3. Okay, back, go. Why only 2 runs? Go. I want 3 runs at least. Very close now. Yes, it is touching. It is definitely touching. Waiting, and signal. Yes. Okay, it has stopped. Data file. What is this? It doesn't do a thing. Nothing in it. That's absurd. No nice data file. But touching of the sensors, did I include that anyway? I can't even remember. Now, as far as I can see, oh, touch sensors, yes, but not into the data file. Aha. Okay. So, going back in the text. No front sensor. And I should see something calling front sensor, which I don't. So it has the register, it has not seen the front sensor being touched. Okay. But I'm in a good, on a good way. This is very nice. I have changed the algorithm a little bit for the front sensors, so I'm going to start it once again and then just touching the front sensors to see if it will be registered. So let's go. No. Yes. Connecting. And touching. Lamp is not defined. Ah! Something called lamp is not defined. And that is only something you can find in this way. What is lamp? Something here? No. Oh, lamp. Lamp is text motor 3. I took it out. Why did I take it out? That is something for next time. Interesting, but for next time. And with these very fine results, despite one error in the last moment, I say thank you for watching. If you like this video, please do subscribe to my channel, give the video a thumbs up and click the bell for notification. Please leave a comment or suggestion, very much appreciated. Please support by making a donation via either PayPal or Ko-fi, or become a patron for as little as €2 or $2 a month. You can also follow me via Twitter and Instagram. Please take a look at my website for more projects on fischertechnik and Arduino, etc. and Raspberry Pi. This is obviously going to be continued. For now, stay safe, have a great day, take care, bye.